Good evening. Today we are going to see a compound bar problem, which you have already studied in strength of material, simple stresses and strain. There we have used equilibrium equation and compatibility equations to analyze the compound bar. Here we are going to use finite element method. So now my channel, that is Civil Engineers Technical Hub, subscribe this channel, and then from this playlist you are in position to see the different videos. So now we will go and we will see the different videos over here in different playlist. Now we will go with first problem, that is the stepped beam ABCD is as shown in figure, determined by FEM, global stiffness matrix, nodal displacements, reaction forces. Now we have given this beam. So we have this as ABCD. So we have this as A, then B, C, then D. Now forces we have applied are 50 kilonewton at B, 100 kilonewton at C. And we are interested to go for these three global stiffness matrix, nodal displacements and reaction forces. So now we will go to this. This is given problem. And we have this will be A, B, C, D. Now we will first give node numbers. So we have to give first primary nodes. So we have this will be primary node 1 and primary node 2, because primary nodes are at ends or at corners. Then we have in between where my element or diameter is changing, force is there. This will be 3 and this will be 4. Now nodes 1 and 3, these are connected by the element, will give number as 1. So I will give this as 1 number. So first element, then 3, 4, I have second element, and then 4, 2, I have third element. Now as we know, for axial member, my stiffness matrix, if you remember, then I have this stiffness matrix K equal to AE by L in bracket 1 minus 1 minus 1 1. Now I will go one by one. I will prepare stiffness matrix first for element 1. So I have K1 is equal to A1E upon L1, 1 minus 1 minus 1 1. Now A1 we have, that is, we have this diameter as 25 millimeters. So pi by 4 into 25 square, and value of E actually given, I have not mentioned in the problem, but this is given in problem, E as 207 kilonewton per mm square. So this is given actually. Now I will convert it into Newton per mm square. So 207 into 10 raised to 3. L1 is 300, 1 minus 1 minus 1, 1. And if we will solve this, I will get 338.7 into 10 raised to 3. Now if you will see, AE by L, we have a minimum for first element, because my diameter that is less for first element, and L value, these are near about same. So here these are increasing, but diameter is increasing fast, 25, 50 and 75, and we have pi by 4 square, 20 diameter square, and therefore this value for 2 and 3 increases. So minimum is this. So I will take 338.7 into 10 raised to 3 common from all elements. Now for element 2, we have K2, A2, E upon L2. We have L2 380, diameter we have 50, and if we will E, we have same 207 into 10 raised to 3. And now if we will solve this, we will get 1069.59 into 10 raised to 3. Now already we have mentioned, in first we have this value, that is 388.7. So we will divide it by 338.7 into 10 raised to 3, and whatever value will remain, that value we will take inside. We will get this division, that is 3.16. And therefore, I will multiply 3.16 to this element, this and this. So now you can see K2 we will get 338.7 into 10 raised to 3, 3.16 minus 3.16, minus 3.16 and 3.16. So this is element 2. Now we will switch over to stiffness matrix for element 3. And we have this is A3 E upon L3, 1 minus 1, minus 1, 1. Now A3 we have D at 75. So we will put it, and L3 we have 460. Now if we will solve this, then we will get it as K3 equal to 1905.2 into 10 raised to 3. Now to keep same value outside the stiffness for global matrix, so we have 338.7 into 10 raised to 3. And if we will solve this, we will get this as 5.63. Now we will multiply this by 5.63, all these elements. And my stiffness matrix becomes 338.7 into 10 raised to 3 and multiply all 1 by 5.63. Now we have these 3 matrix. So now we have to find global stiffness matrix. So this is not for 3, global stiffness matrix. And for global stiffness matrix, we have to use this. Now we have this will be 1, first node, this will be third, then we have first, we have third. Here we have third, you can go and see third node, then we have fourth, third, and we have fourth. And here we have fourth, second, fourth, second. Now stiffness coefficients, if I will write, I have this as S1, 3. I have this as S3, 1. So sorry, this as S1, 1. This will be S1, 1. So just I will write it properly. So we have actually this is 1, 3. So this is 1, 3. Then I have this as 3, 4, 3, 4. And then here we have 4, 2, 4, 2. Now if I will write this, this will be S1, 1. This will be S1, 3. This will be S3, 1. This will be S3, 3. Then S3, 3. Then we have this will be S3, 4. This will be S4, 3. S4, 4. And then if we will go here, so we have S4, 2. 4, 4, sorry. This will be S4, 2. This will be S2, 4. And this will be S2, 2. So we have S4, 4 this value. We have S4, 4 this value. So we have to add this. Similarly, we have this as S3, 3. And then here also we have S3, 3. So we have to add this value. And that will give me global stiffness matrix. We have all, every element matrix, we have 338.7 into 10 raised to 3. And now if we will see this, so we have this will be first, that is K1, and then in this we have K2. So you can see K1 we have over here, these values. I will just remove this ink, and then you can have K1, 1 minus 1 minus 1, 1. Then we have this will be 3.16 minus 3, because we have this as 1, 3, 4, and 2. And same here, 1, 3, 4, and 2. So we have this will be, if you will see, we have this matrix as 1, 3 relate. We have this matrix, that is a red matrix, as 3, 4. And third we have, that is of 2, 4. 4 and 2, I will say. And then we have to add this. Remaining we have 0. And now if I will add this, then I will get this as 3, 3. This will be equal to 4.16. And I will get as 4, 4. That will be 8.79. And this will be my global stiffness matrix. So we have this as global stiffness matrix. So global steepness, and then we have matrix. These are the values. So this will be 4.16, this will be plus 8.79. And now knowing this matrix, we can find remaining part. We have F is equal to K into D. K we have stiffness matrix. F we have forces. K stiffness matrix. D displacement. Now we have four nodes. So at 1, we have to find reaction, which is R1. At 3, so this is 1, 3, 4, 2. At 3, we have force 50 into 10 raised to 3. At 4, we have force 100 into 10 raised to 3. And global stiffness matrix we have just seen. And now we have this as displacement. At 1, we have U1. At 3, U3. U4 at 4. And U2 at 2. But 1 and 2, these are at fixed support. So at fixed support, my displacement is 0. So we have U1 0, we have U2 0. So we will just remove these part. If I will remove 1, 1, if I will remove 4, and then 4, then you will get this matrix. So if we will consider now, so here also we will remove 1, here also we will remove 1, then I will get it as 50 into 10 raised to 3. Then I have 100 into 10 raised to 3, and that is equal to, we have 4.16, we have minus 3.16, minus 3.16, and 8.79, and then multiplied by 338.7 into 10 raised to 3, and then we have this as U3 and U4. So solve these simultaneous equations, and solving this simultaneous equation or matrix, we will get value of U3 0.084 millimeter and U4 0.0638 millimeters. Now if I have to find value of R1, so now you can see R1 we have to multiply this by this. Now U1 0 and then remaining 2 0. So we have minus 1 into U3. So we have minus 1. U3 value we have 0.084, and actually we have to multiply it by this value also, 338.7 into 10 raised to 3. And so if we will solve this, then we will get this value, that is equal to 28.45 into 10 raised to 3 Newton, that I can write 28.45 kilonewtons. And then R2, for R2, again first two are 0, so U1, U3 will not be there. And then U2 we have 0, so we have minus 5.63 into U4. So we have minus 5.63 into 338.7 into 10 raised to 3 into 0.0638. And if you solve this, you will get this value, that is equal to 121.65 into 10 raised to 3 Newton. And that is 121.65 kilonewton with minus sign. Minus sign shows that we have this R1 opposite direction. So I can write over here, you can see this R1 28.45, but direction will be here. R2 121.65 will be here. Likewise, we have to solve the problem. So this is all about this problem. Now we will stop here only. Thank you. Video आवडला असेल तर लाईक करा आणि चॅनलला सबस्क्राईब करा. Thank you.